Hello everyone, my name is Abhishek and welcome back to my channel. So today is day 42 of our complete DevOps course, and in this class we'll be learning about Kubernetes monitoring. So this class is not just going to be a theory, but I have also a GitHub repository that is practical, like you have all the installation steps and whatever we are going to try as part of the demo. The reason why I've created this repository is we are going to do a lot of commands on my minikube cluster. So sometimes people asked me, like, can you put these commands in a GitHub repository, or can you share them as part of a document? So I thought, anyways, I'm going to enhance this repository in the future and add more topics. Like, I'll be adding more topics about advanced Kubernetes monitoring, writing your own metric server. So for all of those things, I thought I will create a centralized GitHub repository, and this is the one. So what you can do is you can star this repository so that you understand what are the future advancements that I'm going to make to this repository. Perfect. But coming to the topic for today, what we are going to learn today is, firstly, we will definitely understand as usual, right? As every class, I'm going to explain the why aspect, like why you need monitoring, what is the advantage of monitoring, what is Prometheus, what is Grafana. So we are going to learn all of those things. After that, I'm going to show you how to install these tools. So the only prerequisite for today's class is you have to have a Kubernetes cluster. That can be anything, like it can be a real Kubernetes cluster on a production, or it can be your development Kubernetes clusters like Minikube, K3s, K3d, anything. We are fine with it, right? We are going to learn about installation, and then finally I'm going to monitor. I'm going to show you how to monitor the Minikube. I'm going to use Minikube. So Minikube Kubernetes cluster using Prometheus and visualize using Grafana, right? So this is going to be an interesting one, and we are going to prepare a Grafana dashboard that will show the metrics of API servers and the deployments that we have on our Kubernetes cluster. What is the status? What are the replicas? We are going to fetch a lot of information from my Kubernetes cluster. So watch the video till the end so that you understand the concept of Prometheus, Grafana, as well as monitoring of Kubernetes clusters. So let's start with why. And like I told you, I've very well documented all of these things. Like, even if you want to follow why monitoring or why Prometheus that I'm going to explain, you can use the same GitHub repository to understand. Whenever in your interviews also, you can use this repository for answering the questions. Firstly, why monitoring is required. So let's say in your organization, you have one Kubernetes cluster. Okay. So whenever you have a single Kubernetes cluster, that's not a problem, because for just one single Kubernetes cluster, probably because you are a single DevOps engineer, what you can do is you can monitor your own Kubernetes cluster. But what happens if this one Kubernetes cluster is used by multiple teams? Let's say you have multiple teams who are accessing this Kubernetes cluster, and one of the teams says that, oh, okay, in my Kubernetes cluster, something is going wrong. Probably they'll say that the deployment is not receiving the request, or they will say that the service is not accessible for a short while. So how do you solve this problem? Or at least how do you understand as a DevOps engineer? Now, this is just one Kubernetes cluster. As the number of Kubernetes clusters increases, probably you have a dev environment, you have staging environment, you have production environment. So your number of Kubernetes clusters keep growing. So as the number of Kubernetes clusters keep growing, then you would definitely need a observability or monitoring platform. So that is where Kubernetes comes into picture. Okay. So Kubernetes was initially developed by SoundCloud. Then it is open sourced. Right now, Kubernetes is Prometheus is a complete open source platform, and anybody can use this Prometheus on their clusters. Like, even if you are running Kubernetes cluster behind, or you are running Kubernetes cluster in your enterprise, you can use Prometheus because it is open sourced one. Perfect. So then if you have Prometheus, what is the requirement of Grafana? So Grafana is basically for the visualization, right? So Prometheus can give you a lot of information using the queries, like you can use the QL queries, and you can get all the information regarding your Kubernetes cluster. But for a better visualization, you will understand when I show you the live demo, you would need a Grafana. So Grafana can use any data sources, and Prometheus can be used as one of the data source. Okay, perfect. Now, so what is the architecture of Prometheus? So sometimes interviewers might ask you this question, can you explain me the architecture of Prometheus? This diagram might look scary, but it is very, very simple. Like you have a Kubernetes cluster. What Prometheus does is, as you install Prometheus, there is a component in Prometheus called as a Prometheus server. So this Prometheus server, what it does is it has a HTTP server, and the Prometheus collects all the information like from your Kubernetes cluster. By default, your Kubernetes has a API server, and API server exposes a lot of metrics about your Kubernetes cluster. Okay, so maybe 5 years or 6 years ago, you might have to do a lot of configuration for your Kubernetes cluster, but right now these tools are very matured. Even they have contributed back to Kubernetes, so a lot of metrics are exposed out of the box in your Kubernetes cluster. Previously, maybe you have to do a lot of configuration for your Kubernetes, but right now the number of configurations has gone down. So Kubernetes has an inbuilt API server. Okay, so this inbuilt API server exposes a lot of metrics. So it says, if you access me on API server slash metrics, API server IP slash metrics, you can get all the information of what is the status of your resources in the Kubernetes cluster, some of the default resources. Now Prometheus will try to fetch this information, and it stores the entire information in a time series database. Okay, so what is time series database? It's just like, with respect to the timestamp, it stores the information of the metrics of your Kubernetes cluster. So this is about the default Kubernetes resources, right? But what if you want to do more resources, or what if you want to get beyond the out of the box metrics that your Kubernetes API server is using? That also we are going to learn today. Okay, so don't worry about it. Then it stores all of these things on the disk, right? So HDD or SSD, whatever you are using. So because it has to store, this is a time series database, it has to store information somewhere, right? It stores on a node using on the HDD or SSD. Then it has a monitoring system, like, you can configure Prometheus with alert manager, and you can send notifications to different platforms. Probably you can send to Slack, you can do an email, you can send to various things. So what happens under the hood is, if you create the alert manager, so Prometheus can push the alerts to the alert manager, and you can configure this alert manager to send out notifications to different places. Probably in my organization, let's say I have decided to use Slack for alerting. So what happens is, whenever Prometheus identifies, you can say what kind of metrics or what kind of alerts have to be pushed. Let's say I say that if API server is not responding according to my limit that I've set, then what you can say is, Prometheus, send an alert to alert manager. So Prometheus will send the alert to alert manager saying that API server, Kubernetes API server is, sometimes showing a flaky behavior, or it is not responding a few times. So this alert manager, depending upon the number of things that you have configured with alert manager, it's not just one thing. Probably you can do email, you can do Slack, you can do Meet, Google Meet, anything, right? So you can send notifications to multiple places. So that's what alert manager does. And apart from that, like, this is about the default configuration, right? But somebody can also go to Prometheus server. Like, Prometheus provides a very good UI, so you can also go to the Prometheus UI, and you can execute some PromQL queries. PromQL is nothing but Prometheus queries. So you can execute some Prometheus queries to get the information from Prometheus, whatever it has recorded. Or you can also use dashboards like Grafana, or like any other tool. Like, for example, AWS supports API, right? So Prometheus also supports API. You can also do some curl commands, or using Postman, you can get that information from Prometheus as well. So this is overall like the high level architecture of Prometheus. So as we keep learning Prometheus, this architecture looks even more simple. Now, like I told you, why Grafana? So Grafana is just for the data visualization. So here, when you do a query to Prometheus, it gives you output in a format. For example, any tool that is returning you output, let's say it is giving output in JSON format. And if your managers, or if you want to set up dashboards in your organization somewhere, so that everybody can monitor, JSON or any kind of this templating languages are difficult to read, right? So if you have a lot of information, it is very easy to represent the information in charts, or any kind of diagrams. So that's what Grafana does for you. So it provides a very good visualization. It retrieves the information from Prometheus. You can configure Prometheus as a data source, and you can get the information into Grafana. And inside the Grafana, what you can do is, you can create some nice diagrams. This is for layman understanding. Okay, so you can create some nice charts or visualization. So now without wasting any time, let's start our demo. And what I'm going to do here is, I'm just going to take a Kubernetes cluster. So I'll create right from scratch, so that many people have been asking me how to create a Kubernetes cluster. Even though I've explained that in the previous videos, no worries, I can do it one more time. So I'm using Minikube for this demo. Uh, Most of the times I use kind whenever I'm doing my local development, or whenever I'm doing local testing, because kind is a very lightweight Kubernetes in Docker Kubernetes cluster. But whenever you're doing this kind of demos which requires more memory, or which requires more CPU, go with Minikube. So one thing that you can do is you can simply say Minikube start. But when you say Minikube start, let's say you're on Windows or Mac, it uses the Docker driver as default. So that means to say that the default driver which Minikube is using is Docker. But for better or easy networking configurations, go with the virtualization. Like in my case, I prefer Hyperkit. Okay, so this is the command that I used to start my Minikube cluster. And if you're on Mac, definitely use this. Hyperkit is a default virtualization that is available on your Mac, or supported on the Mac. But you can also go with VirtualBox, Oracle VirtualBox, or any other platform as well. Okay, so this is the command that I'm using, Minikube start. I'm giving 4 GB of memory and driver as Hyperkit. So if you don't provide this driver as Hyperkit, then it would use the Docker desktop. So whenever you're using the Docker desktop, sometimes when you're exposing your services, or when you're using ingress, maybe you might have to do some additional networking configuration. So this doesn't take much time. It would take probably a minute to create your Kubernetes cluster. And once your Kubernetes cluster is ready, what we can do is go back to this GitHub repository, right? So in this GitHub repository, I have created a folder called installation, and you have installation for both of the things. Like you can use Prometheus folder for installing, understanding how to install Prometheus. You can use Grafana for understanding how to use Grafana or install Grafana, right? So I will also use the same GitHub repository. Perfect. This would need a minute more for creating the Minikube Kubernetes cluster using Hyperkit. Perfect. So my Kubernetes cluster is ready. I've installed the latest version of the Kubernetes cluster, that is 1. Whatever is supported out of the box with my installation. So it has 1.23.3. I did not pass any additional configuration. So probably in your case, you might be installing 1.25. That doesn't matter. Okay, so I'll show you that my Kubernetes cluster, if I just say kubectl get pods -a, so you will notice that it just has all the default installations that like the Kubernetes API server, controller manager, code DNS, etcd, only these things, right? So let me proceed now and start with the installation of Prometheus. So I would go with the Helm as installation option, or operators as installation option. Okay, so either use Helm or use operators. This is not just for these tools. In a general practice, operators offer a lot of advanced capabilities. Like you can do lifecycle management of your Kubernetes controllers using operators, where you can install it, you can configure for automatic upgrades. Let's say tomorrow there is a new version of Prometheus. Operators are capable of upgrading your Prometheus automatically, and they can do a lot of more things. We will talk when we discuss about Kubernetes operators. So in this class, I'm going to install using Helm. So I will just open the GitHub page that I've shown you in a different screen. And what I'm going to do is I'm just going to copy paste the commands. So the first command that you will see in the GitHub page, probably if you're watching the video, you can open the GitHub page in a new tab, or if you have a different screen, you can open it there. So I'm just copied it, and it says Helm repo add Prometheus community. And so what I'm doing here, I'm just adding a Helm chart. So first thing that you need to do when you're using Helm is to add the Helm repo, right? So that's what I'm doing here. In my case, it is already existing, but in your case, if it is not available, like you can do it, you can install it, you can add the repo, I means to say. Now, Helm repo update. So this would update if you have, let's say you have installed this repo a week back, and now there is a new version of Prometheus controller. So always do Helm repo update before you install anything. So here in this case, when I do Helm repo update, so it updated a few things successfully. Perfect. After that, I would simply install the Prometheus controller, right? So this is the step to install the Prometheus controller and the other required configurations like the Prometheus config map and the other things. Perfect. Helm install Prometheus community. So you could also do this step directly if you had the Helm chat. But what happens if you don't do Helm repo update? Probably you might install an old version of Prometheus. No problem. So I have installed, I'm going to install Prometheus now. So it says perfect. So Prometheus is successfully installed. And what it says, like just copy this information. Do not run to the next command, because here it gives you some important information on how to, like, how to get the server URL. Probably if you're not using Minikube, maybe if you're using OpenShift platform, or if you're using a different platform. So this information is very important for you. So read the information, whatever is provided here. And probably if you want to do port forwarding, all of these things is available. But in this class, I'm going to explain you all of these things. So you can skip, but always try to read these things. So I've done the Helm install. Perfect. Now the Prometheus install. Let me see if it is installed right or not. kubectl get pods. Uh, it should run Prometheus pods. Perfect. So the Prometheus pods are running. So Prometheus server is still running, right? So if you see here, it says Prometheus server. So the container is creating. Even in this case, kube-state-metrics. I'll explain you what is kube-state-metrics and what is the importance of kube-state-metrics, but you can understand that it is still running. Okay, so let's give it a minute. So this is running now, kube-state-metrics, and this is taking more time. So meanwhile, I can explain you what is kube-state-metrics. So like I told you, Kubernetes API server, it exposes few metrics of your Kubernetes, right? So it gives you information about the Kubernetes API server. It gives you information about the default installations on your Kubernetes cluster, which I showed you a couple of minutes ago. But as you are monitoring your Kubernetes clusters, you might require more information. Probably you might want to know information about all the deployments, all the pods, all the services on your Kubernetes cluster. You would want to know if the replica count is matching the expected replica count of all the deployments on your Kubernetes cluster. So what the Kubernetes community, or what people at kube-state-metrics have done is they have created a kube-state-metrics controller. So you can create a service for this kube-state-metrics, and you can use this kube-state-metrics. So when you call the kube-state-metrics on the metrics endpoint, so it would give you a lot of information about your existing Kubernetes cluster. So this information is beyond the information your Kubernetes API server is providing. So that is the importance of this specific Kubernetes controller. So when you install using Helm, this is installed by default. Let's say you are not using Helm, or let's say you are installing just the Prometheus deployment. So I'll also show you that what happens in that case. Let's say you are not using Helm chat and you have not installed this. I'll show you how to install this by your own, right? How to install kube-state-metrics. So before that, let me just say kubectl get pods and see if everything is running. Perfect. Now everything is running and I am good to go. So now what I will do is I will just see kubectl get svc. So all the services here. So there are services like Prometheus server. So this is a service that is created using cluster IP mode. And you have again this one, which is very important. Prometheus kube-state-metrics that is also created on the cluster IP mode. So and then alert manager that I told you. So all of these things are created using cluster IP. But what I want to do is I want to expose this Prometheus server, and I want to show you how does the Prometheus server API would look like, and what queries that you can create, or all of these things. So for that, what you can do is firstly convert this cluster IP mode service into a node port service. So what you can do is go to the documentation and simply use the command that I've provided. So this is kubectl expose service command. So what it would do is as soon as I enter this one, Okay, so you would see a new entry here. Let me just do again kubectl get svc. So you would do see a new entry called Prometheus server ext, because in the command I have provided expose a service, and the name of the expose service should be Prometheus server ext. Okay, so now what I can do is I can open the Prometheus server UI on the node port 31,000 31110, right? So let me go back, take the terminal here, right? And show this to you. So before that, I need to get the IP address of my Kubernetes node. So I can just do minikube IP. So if I do minikube IP, this is the IP address. So go back, take the browser, enter this one here, HTTP colon, what was the port again? Sorry, 31,110, right? So 31110. So see that the Prometheus is running. So you have installed Prometheus on your Kubernetes cluster. So right, so you have done the step one successfully. So now what you can do is you can provide any Prometheus queries, right? Let's say you're not aware of Prometheus queries. You can just read the Prometheus documentation, or you can also use ChatGPT to just give information about a few Prometheus queries. And as soon as you execute this Prometheus queries here, I'll show you, don't worry about that. So you can get the information about your Kubernetes cluster. So by default, like I told you, you can only get the information of the metrics that are exposed by your Kubernetes API server. So if you have a application, let's say you have an application called XYZ that your developers have deployed on your Kubernetes cluster, and you want to get the health checks of it, or you want to get liveliness probe, or you want to get any details of that particular application using, I mean, at this point of time, it will not be possible, because the API server or the kube-state-metrics, they will only give you the information at a certain level. But if you want to get more details of your application, then your developer should write a metric server, or they can use the Prometheus metrics libraries. And what they can do is they can expose a metrics endpoint, and you can scrape that metrics inside the Prometheus. That I'll show you how to do that. In Prometheus, you will have a config map, and inside that config map, you can scrape the metrics. So you can say Prometheus that, okay, apart from the metrics that Abhishek is going to show me in the Grafana board or here, what I want to do additionally is I also want to get the metrics of my custom application, or the application that my developer has deployed. And apart from the default metrics, kube-state metrics is giving me, I want some additional metrics. Okay, so let's not bother about it for a while. So for now, you have the Prometheus, and Prometheus is installed. Now, what I'm going to show you is the advantage of this one here, Prometheus kube-state-metrics, right? So what is the advantage of it? Maybe we'll firstly create Grafana, and then we will come back. Okay, so that you understand what are the default metrics that Kubernetes API server is giving, and what is the advantage of this state metrics, which is going to give you additional metrics. So again, I'll go back to the document here. So if you go to the GitHub, so there is a folder called Grafana. Just go to the Grafana folder, and you have helm.md. So just copy the commands step by step. And every time you do it, verify that your command is passing. So let me just copy the first command to add Grafana Helm chat. So now the Grafana in my case already exists. Probably in your case, it does not exist. And it is always a good practice to do Helm repo update after that. So I have updated the Helm repo as well. Then I'll proceed with installing the Grafana using the Grafana Helm chat. So now this should install the Grafana on my Kubernetes Minikube cluster. So it doesn't take much time, and you will notice here that it is very important now to follow these steps, because you need to know the password for your Grafana. Okay, so to log into Grafana, or to visualize the information from Prometheus on your Grafana dashboard, what you need to have is the password to log into Grafana. So you can get that password here. You can simply copy the command which says kubectl get secret, and admin is the user, and the password in this case, oh sorry, again copy it. So this is the password in my case. Okay. So now let me try to expose this Grafana. Similarly, I've done to my Prometheus, because if you just do kubectl get svc, you will notice that there is a Grafana service, but this Grafana service is again here running on the cluster IP. So let me expose this one and create a node port mode Grafana service. Okay, so you will notice a new entry. Oh, sorry, there is a typo here. I think I need to fix this on the GitHub page as well. No problem. So now you will notice that a new service entry would be created. If I just say kubectl get svc, you will notice that there is something called as Grafana ext. In your production environments or in your dev staging environments, you don't have to do this, because you will definitely use ingress. You will have an ingress controller, so you can create an ingress or route for your Grafana and you can start using that. If you're using an operator, then that would be automatically created. You don't even have to do that. So now the node port IP address for this is 31281. Okay. So again, minikube IP. So this is the IP address and 31281 is the port. So let me take this one here and again show you. Let me open a new tab, copy it, http colon 31281. Now you should see Grafana dashboard as well. Right? So it will ask you for the user ID and password. I explained you how to get the password right. So if you don't remember, go back and what was the command that I've executed? Kubectl get secret namespace, and this was the password that it generated for me. So enter the password here, and now you are able to log into Grafana as well, right? So now you have successfully set up Prometheus as well as Grafana for your Kubernetes Minikube cluster. Awesome. So the first thing that you should do as soon as you have Grafana is you need to create Prometheus as a data source for your Grafana. Now, why is this required? Because like I told you, Grafana is a visualization platform. So it would need some metrics, or it would need some information for it to create all the charts or all the required diagrams. So creating that is not difficult. Just go to this option here called data source, add your first data source, click on it. So you would have option for multiple data sources. Like I told you, Prometheus supports a lot of data sources, but sorry, Grafana supports a lot of data sources. We are interested about Prometheus. So click on Prometheus. Provide the IP address of your Prometheus. So in my case, I can copy it from here and paste it here, right? So this is the IP address, and save and test. So that would save the configuration, and it will also test if your data source is working or not. So here it said data source is working. That means to say now my Prometheus will be able to, sorry again, sorry for that. Now my Grafana will be able to retrieve the information from Prometheus. It can use Prometheus as the data source, and it can show you some dashboards. So let me go and create a dashboard as well. So click on the dashboards option here, and you can do it from here. And what you can do is, instead of creating your first dashboard, because you have to do a lot of things, the simplest thing that you can do is come here, click on a dashboards option. Here you have something called as import. So what Grafana has done for you is, Grafana says that, okay, you don't have to create anything. So in grafana.com, we have created multiple dashboards. Like dashboards are nothing but they have created some predefined queries, and anybody who is going to use that dashboard ID. Okay, so we will automatically configure some queries to pull the information from Prometheus. So if you are starting with Grafana, use this ID called 3326. Just click on load, and your first dashboard not found. Okay, what was the problem? Let me try it one more time. 3326. Just give me a second. Sorry, my bad. The ID name would be 3662. It's not, sorry for that. Yeah, as soon as you click on the load, so you will see here that you can choose what is the default option, that is Prometheus again. So just click on import, and you will notice that beautiful dashboard is created for you, and this dashboard is retrieving the information from your minikube cluster. Now how did this happen? So as soon as you entered an ID called 3326, what the people, or what the Grafana dashboard that is available for you at the grafana.com has done is it has created a pre-existing, or a pre-created template, and that template would run queries. Like here I have shown you one diagram. If we go back, so here what I told you in the initial slide is, if you want to get any information from the Prometheus server through Grafana, you have to run some PromQL queries, right? For if you are a beginner, you might not know about this PromQL queries. Maybe you have to learn, or you will take more time to understand how to write this PromQL queries. So what Grafana said is, okay, don't worry, we'll make it easy. We have noted down what are some of the common queries, or what are some of the standard queries that everybody would require, and we have created a template for it, and that template ID is 3662. So 3662 in the Grafana is a standard template that would get lot of information from your Kubernetes cluster. See, now we are able to get the information of Kubernetes API server, Kubernetes nodes, all of the things, right? So you can just go on one specific thing. Just click on Kubernetes nodes. So here you have the information of the Kubernetes nodes. And probably if you want to get any information about what is the uptime of your minikube cluster, so it says minikube cluster is always running, and if you just hover on it, so it will give you the query as well. Okay, so slightly hover on it. uh, yeah, so it is sometimes difficult to capture that view. Just give me a moment. Okay, no problem. Like, you can hover on it and you can get the query as well. Okay, so as soon as I'm doing it, I'm not able to copy it and show it to people, but you can get all of these queries to understand, or you can also go to, like, see here. So it is saying it has executed a query called sum, and it is getting the time series of all the things. What is the memory chunks, or what are some of the missed iterations? So all of these things, and this is a real-time dashboard. So you can get this information. uh, Even if you execute this query that I'm showing you here now, average over time of up status of my Kubernetes node, so you are going to get the output in the Prometheus as 100. Okay, so you can execute that queries here as well. But like I told you, if you are going to execute the queries here inside the Prometheus, what will happen is you are going to get the information in a JSON format. But for a better visualization, go for Grafana. You can use the similar queries in Grafana as well. Now, but here if you see, what is happening is I have the metrics regarding the native Kubernetes services. Like you have Kubernetes API server, you have few other components. But what if I would like to know what is the deployment status? What are the running replicas? Or what is the current status of the Kubernetes service from Prometheus? So that's why what Prometheus has done, or what this specific service that I'm going to talk is kube-state-metrics. So this one here, kubectl get SVC. So this is the kube-state-metrics, and this is going to give you a lot of more information. Okay, so again, similar to the previous things, I'll try to expose this kube-state-metrics, and I'm going to show you. Okay, so the command that we're going to use is just say expose, and use this one here, followed by what is the target port. So how do you understand the target port? So if you look at the kube-state-metrics, so the target port is 8080. So 8080. And let us name it as kube-state-metrics -ext. Now, once I run this, you will get a new entry for this Prometheus kube-state-metrics as well. So let me do kubectl get svc one more time. And now you will notice that the kube-state-metrics is running on 30421. Now see the magic. What would happen if I just use the same minikube IP address, but on the port 30421? Okay, so let me do that. What is the minikube IP address? http://192.168.64.15. Or let me copy it from the cluster only. copy colon 30421. Now see, so it says, let me increase the font. It says, okay, so you are trying to reach cube metrics, and if you click on metrics, so you get metrics of a lot of things on your Kubernetes cluster. Okay, so like I told you, this is a JSON format information, not JSON actually. So this is a metrics format information where you are getting a lot of information, right? But now what you can do is, see, you can use this same information inside your Grafana as well, or take any of this query. Like for example, I would like to know what is the status of deployments. Okay, so you can just use the Prometheus query here called this one. So what it is doing is it would give me status of my Prometheus server. So you can take this query here and you can execute it like this. And as soon as you do execute, see, this is the information that Prometheus has returned you. And what Grafana will do is it will take the same information, but it will provide you this information in a visualization pattern. Okay, so that's the only difference. Like the information is coming from Prometheus itself. Grafana is just using Prometheus as a data source, and it is providing you this information in a visualization format. Okay, so it is providing you this information in a better format. Now, what you have done till now is that you have set up Prometheus, you have set up Grafana, and you have used the default dashboard in the Grafana, that is 3662 ID. That's a default template which will retrieve a lot of information about your Kubernetes cluster. What is your nodes uptime? What is the status of your Kubernetes API server? What is the status of your Kubernetes etcd? All of these things is available. Let's say if your organization requires more information, then what you can do as a DevOps engineer, you can expose the kube state metrics and you can get a lot of information on this specific endpoint. Okay, what is the endpoint here? 192.168.64.15 is my minikube IP address, followed by the node port of my kube state metrics / metrics. Okay, so this is the endpoint where you are going to achieve or get all the information. Now you might ask me, okay, so I am doing this on the browser, but how do I do this information inside my Prometheus? Like, how do I get this information directly inside my Prometheus? So again, it's not a rocket science. What you need to do is you can just do kubectl get cm. So this is the config map called Prometheus server. Okay, just open this Prometheus server. Okay, kubectl edit cm config map called Prometheus server, and here you have information about all the data that your Prometheus is scraping. Okay, so scrape information is nothing but the information that Prometheus is getting from. Like you have a prometheus.yaml file, and here you have scrape configs. So by default, what it is saying is it is just getting the information from the local host 9090. But where I want the new information should be coming from, so I want the new information should be coming from this specific endpoint 192.168.64.15 304.2y. Sorry, 21, right? So this is the new information that I want. So what I can do is I can create a new entry inside my Kubernetes cluster for this kube state metrics endpoint. So here I would add a new configuration. How would I do that? I can simply come here. Okay, so provide a new job name, and here you can say state metrics or anything that you would like to. And here you would say static configs and put the same information and provide the target IP address. Okay, now the important information is, okay, so this is about kube state metrics and this is about the default Prometheus metrics, but what about the applications my developers are writing? So my developers are writing bunch of applications, and how do I get the health of those applications? So how do I understand if that applications are receiving, or they are sending out response on each and every request? So how do you get that information? Is you should ask your developers, right? Similar to this kube state metrics, it is exposing all the metrics regarding the Kubernetes default applications on /metric endpoint, right? So similarly, you should ask your developers to write a metric server, and what they will do is they will write a metric server and they will use the Prometheus libraries. There is a very good documentation that is available. As a DevOps engineer, if you are not writing these things, it is not required. But let's say you are interested, what you can do is you can just search for Prometheus metric server. How do I write that? I will also explain you that in the future classes. So once your developers or DevOps engineers writes that, then it is all about just going back and updating your application's metrics here. Okay, so this is very simple, and this is how you are going to do monitoring and visualization using Prometheus and Grafana, right? I hope you understood what we have done today. And if you want to replicate the same behavior, if you want to try out the same things at your end, then you can follow this documentation where I have detailed each and every step. Okay, whatever I have done till now, and probably the cube state metrics information is missing, so that thing you can understand from the video because it is just one command. Okay, and so yeah, so this is the video for today. If you like the video, click on the like button. If you have any questions or any feedback for me, put that in the comment section. I hope you enjoyed the video. Please share the video with your friends. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.